Hello guys, welcome to the list section. In this section, we'll discuss another data structure named list. Okay, a list is a class that accomplishes the same task as arrays. As we said, an array is a data structure that stores multiple values in a variable. As you know, in an array, the elements are stored next to each other in memory, and the array's variable points to the first element. By using the memory location of the first element and knowing the size of each element, our application can easily access any element within the array. Okay, lists do the same thing but with a different approach. But how? Before going any further, it's important to know that there are three types of lists: array list, linked list, and list. In the upcoming courses, we'll explore array list and linked list structures. For now, let's illustrate how lists work with an example. Okay, under the hood, lists use an array to store their elements. This means that when we initialize a variable with an instance of a list class, the list creates an internal array. The key members of the list class are items, count, and capacity. Items holds the elements of the list. Count represents the number of elements contained in the list. Capacity denotes the total number of elements the list can hold. Okay, here, when we create an instance of the list class, both the count and capacity values are initially set to 0. Next, when we add the first element to the list, the capacity increases to 4. The element is stored in the index 0 of the items array. And the count value becomes 1. As we add the second, third, and fourth elements to the list, the count value increases by 1 each time, while the capacity remains unchanged. But there is a different situation when adding the fifth element. In fact, before adding each element, the list checks if the count is smaller than the capacity. If it is, the element is added to the list. However, when adding the fifth element, the count is equal to the capacity. In these cases, the list expands by creating a new array that is twice as big as before. It then adds the new element along with the existing elements to the new array. Now, the count becomes 5. And the capacity increases to 8. Also, items point to the first element of the new array. This process continues as more elements are added using the same approach. It's worth noting that the old array eventually be cleaned up by the CLR. Okay, this is how lists store elements in memory. And as you can see, they utilize an array to organize the elements in a linear manner. However, arrays and lists have some differences. The key difference between them is that arrays have a fixed size, meaning that once we define an array with a specific length, we cannot change its size. On the other hand, lists have a dynamic size and can grow or shrink as needed. We can add or remove elements from a list without having to worry about resizing. Alright, arrays are best used when we know the size of the collection in advance and need to access elements quickly, while lists are more flexible and easier to use when we need to add or remove elements dynamically. In real-world applications, most of the time we use lists to manage our data collection. Okay, done. See you soon.